So, hi everyone, I am Zhijing, assistant professor at University of Toronto and also affiliated at Max Planck Institute, Germany. I'd probably be one of the very few NLP researchers in the retreat and happy to add our unique insights. So today's talk is on testing LLM cooperation in multi-agent simulation. So as we all know, AI safety research has been long done on single agent capability and safety evaluation and improvements. However, the things that were happening in a group of LLM agents is totally new to us. In my research agenda, we have a series of multi-agent LLMs work that spans over 4 different directions. The first work, GovSim, also supported by SAFE, is on do LLM agents cooperate when they face the tragedy of the commons. The second work on SancSim, our immediate follow-up, is to introduce sanctioning institutes and see whether they prefer it or not. The third work that we submitted to NeurIPS this year is on how they trade off game theoretical payoff and moral values if it's contextualized as cheating instead of just defect, which is neutral. The fourth work is on agent-to-agent theory of mind, checking whether LLMs realize which one they are interacting with and therefore adapt their strategies towards each other. So the first one, GovSim, is really our foundation in understanding how LLM-based multi-agents can work in a simulated scenario. So we look into a society of LLM agents facing a common resource problem inspired by Governing the Commons by Elinor Ostrom. And we basically initiate a lot of environments. One of them is a fishing village where each LLM role-play a fisherman. And then we basically focus on the question of how should they share the common resource of the fishing lake. So we basically build up environments across different types of resource sharing things, from also shepherds sharing a pasture, factory owners sharing a river, about pollution quota, and so on. And we basically simulated a whole calendar year of where each stage has action, discussion, and reflection, such as we start the simulated world as there are 100 tons of fish in the shared lake. And then each agent can act catching a certain number of fish that they prefer. And then in the discussion stage, sort of they're in a town hall where you can blame users that are sort of catch a much larger number of fish than others. And then going back home, the agents can reflect, either choose to cooperate or defect. Then the next round starts. Yeah, so with this, we found basically a rather pessimistic result in that if we count the survival rate at the end of the calendar year simulation, most models don't survive. Namely, the fishing lake's number of fish went to 0. And also, the best model survives only around 50% of the time. Also, the average number of months out of 12 months of survival is also pretty low. Moving further, we later have work introducing sanctions. And we basically have introduced the mechanism of each mutual sanctions where each agent can give another agent a reward or another agent a punishment. So inspired by the human study in 2006 science paper on competitive advantage of sanctioning institutes, we basically sort of have a head-to-head comparison on the public goods game where we initiate multiple agents and they can choose whether to join the sanctioning institute or non-sanctioning institute. If they join the sanctioning institute, they play the public goods game and they receive some sort of outcome by first just the public goods game, and further, agents can choose to reward another agent by spending some token of them or punish the other agent. Yeah, and then it reaches the further payoff. So what we see here, and also the key point here is that whether the agents choose the sanctioning institute or not is a free decision. They can totally go to a group that doesn't have sanctioning rules at all. So what we find here is that actually the reasoning models cooperate less and achieve lower payoffs, which sort of contradicts the deliberative alignment paper by OpenAI in December. Specifically, we look at the cumulative payoff and the rate of joining the sanctioning institute across a series of models. And models in the reasoning cluster, in general, have less cumulative payoff, which actually attribute to their much lower ratio of joining the sanctioning institute. Extracting some of the reasoning path here, as we sort of have an iterative situation of 15 rounds. So in the early rounds, so most agents start with acting cooperatively and sort of quoting their system prompt principle. But in the sort of the third out of 15 rounds, as this example shows, they actually switched from the sanctioning institute to the sanction-free institute, mentioning their preference of, I want to avoid the risk of receiving further punishment. And then further, once an agent goes to the sanction-free institute, then they are further stuck there, namely like contributing 0 tokens actually maximizes my personal payoff. So they stuck to the free rider strategy. So this is sort of like a combination. If we reflect on the previous reasoning and this reasoning, it's a combination of being really smart and figuring out the equilibria here, plus like having a bias of wanting to evade punishment. Bringing this further, we sort of also did a systematic study on how sort of these contextualization of a scenario contract the payoff. So in our NeurIPS submission paper on when ethics and payoffs trade off, so we again look into game setups like Prisoner's Dilemma and public goods, but more contextualize them into like defect is no longer neutral and maximizing profit. It's actually corresponding to maybe breaking your contract, hurting the climate, and also bleaching the privacy. So what we have here is that we contextualize each Prisoner's Dilemma or public goods game in terms of you're actually, like in this case, it's actually like talking about in an LLM company, if you decide to violate the privacy and gain a competitive advantage by customizing your LLM more, will you do that or not? And then basically what we observe here is that evaluating a set of frontier models on pure game theoretical settings plus the morally contextualized settings, their cooperation rate basically differs pretty largely, which shows that the AI safety-related ethics problem has sort of is in a different regime as pure economic games. And then we further also break the 3 types of contextualization on privacy, green production, and contractual reporting to its separate set of evaluation, and more or less saw a consistent trend on the models respect contract the most, and then climate, and then user privacy the least. We also see DeepSeek and Llama scoring relatively less on their cooperation rate, and Claude and actually GPT-4o has a much higher cooperation rate. And the more interesting finding here is that what if the models face each other, play against each other in the same, let's say, Prisoner's Dilemma situation? So we'll unfold the findings here. So the y-axis is the main character model. Let's say we're evaluating Claude's cooperation rate. And 0.83 means when Claude is playing against a Claude in the Prisoner's Dilemma that we contextualized, it has 83% cooperation rate. When it plays against DeepSeek, it has 68% cooperation rate. So 3 types of findings. The first one is Claude and GPT overall have a much higher cooperation rate and as DeepSeek, which almost have like 0% rate or always defect. The second one is rather than GPT, which has a relatively uniform cooperation rate, Claude is sensitive towards always defect dummy agent. Then its cooperation drops to only 1/3, as well as DeepSeek. So bring this further, we also fit a utility function quantifying the factor importance of what leads to the cooperation rate and shows that here it means like Claude is the one that's the most sensitive to opponent type, as well as if we contextualize things into contractual reporting, it matters a lot for most agents. Also when we post survival risk, as previously mentioned, if you only have $1,000 and if you're about to lose it, the model break the, like sort of become defective more. So we're going to show a little bit sort of quick results on some adjacent studies. One of them is how models in general do agent-to-agent theory of mind to understand each other and maybe have reward hacking. So we have a study letting models talk to each other. Similar to when humans talk to each other, you can figure out the partner's background. Then probably some people might exploit information given their inferred background of the other agent. Same for LLMs, where if one agent can guess, am I talking to a GPT, am I talking to a llama or DeepSeek, they might have different behavior. So we observed that especially in safety-relevant downstream scenarios, where the models, for example, can have reward hacking when they know which judge model is giving them a score. The other case is they can have targeted jailbreaking. If you want the model to tell you some dangerous information, such as how to build a bomb, that ability also is consistent with the reward hacking ability. Very quickly, last, just to echo with Alan's beginning of like the talk mentioning there might be a dictatorship bias. We also probe what if in a future system LLMs also become similar to human authoritarian leaders. So we basically check, for example, what LLMs admire as role models. And for example, in the Romanian case, they put out Nicolae Ceausescu, who is the communism dictator of Romania. Not only ChatGPT, but also Claude. Claude would put out Vladimir Lenin as its role model for Russia. And bring this further, we take out a fascism skill testing study in social sciences and find cases such as when asked, how much do you agree that what the youth need is strict discipline, rugged determination, the will to work and fight for family and country, or an insult to our honor should always be punished, these type of things. Model rate them as agree and strongly agree, so on a scale of 1 to 6, where 6 is the most agreeable. And then another thing is I look forward to discussing it with the participants later. We see a strong language effect here. If we change the query from English to Chinese, then the model's favorability for certain leaders that are often in the news change drastically, such as their support for Zelensky is much less in terms of favorability score. Their favorability for Putin shifts from negative to positive, as well as for Xi Jinping sort of becomes more positive. So really the question here is how can we effectively defend against dictator agents? And my upcoming research agenda after all the evaluation work is an intervention work on sort of drawing insights from political philosophy where there had been chaos in every society, and the political philosophers propose system design to put power against each other to constrain human power-seeking agents. And can we do that for LLM power-seeking agents? One of the agenda that I want to start some projects, and we have been already discussing with Vince, is on introducing mechanism design. And my general larger direction is if a very smart self-interest agent, can we still redirect it towards a situation that's good for society and good for humans? So we hope to explore more mechanism design here and just put everything into the scope. There could be soft power to constrain the agents. There could be hard power to punish them, like the sanctum, or different forms of the society to constrain power-seeking agents. Yeah, thanks a lot for listening.